In this video, we are going to look at conservation of momentum in 2D. So the situation is like this, that we have a mass of, say, m is equals to 2 kilogram. It is moving due east, and the velocity is say 17 meter per second, and other object we got which is moving towards north, and its mass is suppose 3 kilogram, and it is moving north with a velocity of 15 meter per second. And the both of them combine and they collide, and after colliding they both combine, they fuse together, and then as a combined mass they move. So they will go, this become combined mass, and they go in this direction here. And we need to find the velocity of combined mass. Okay, now we can take that as an isolated system, which means that the principle of conservation of momentum applies, and we need to just set the initial total momentum, and the final total momentum, we need to set them equal. We need to make them equal, and that would give us a way of finding the final velocity here. Yes, so we are going to find the initial momentum first. Total, I can write this thing in words as well. Total momentum before collision equals to total momentum after collision. Total momentum after collision. So first we will find the total momentum before collision. Now before collision, the total momentum consists of two momenta. We got momentum of object 1 here, and then we got momentum of object 2. So we need to add them together. So this is my, say, m1, and this is, say, m2. So p1I is the initial momentum of object 1, and I'll show that as a vector, which is mass time velocity. 2 times 17 is equals to 34 Newton second, and it is due east. As we can see, the velocity is in this direction here. And P2I, which is the initial momentum of second object. Initially means before collision. We got mass time velocity, which is equals to 45 Newton second due north. So to find the total momentum, we need to vectorially add them together. So what we have is total initial momentum Pi is equals to P1I plus 2I, and this is a vector addition we are talking about. So all we need to do is we need to vectorially add them together, draw them, and then find the total momentum, so final momentum. So I will draw this first one here, which is this is my Pi, and the length of this vector is 34, and from here I need to draw the other one, and that goes like this. The length is 45 here, and this is P1I, and that is P2I, and the total momentum is, when you add them together, this is your Pi. Alright, so let me use all the room there. So using Pythagoras theorem, we can find the length of this hypotenuse here in this triangle. So Pi is equals to square root of 45 square plus 34 square. Putting that in calculator, we get 56.4 Newton second. That's the length, but we also need to find the direction. So I'm going to say that this angle is theta and I need to find theta. So theta is equals to tan inverse 45 over 34, which gives me an angle of 52.93 degrees. I can now write my Pi completely. I say that P initial momentum, total initial momentum is equals to 56.4 Newton second, and this is direction from east 52.93 degrees towards north. That is my Pi, and I need to find Pf. So I need to find this. I have total mass because the mass is combined now. They move as a single mass now. So that is equals to 2 plus 3 is equals to 5 kilogram. And we need to find. This is the velocity, final velocity that we need to find. So I can write Pf is equals to m times v. So 5 times v, I'll just write that as 5v. And v, I will just say that is unit is meter per second. So I'll just say that's Newton second. Right, so whatever is the v, whatever the value of v we have here, that will give us Pf, and value of v means we are talking about value of vector v, including magnitude as well as the direction. So because of principle of conservation of momentum, we have Pf is equals to, if we want, you can write that as with the arrow as well, just to show that it's a vector we are talking about here. Pf is equals to Pi, which gives you 5v is equals to Pi we already found here. So 56.4 Newton second east, 50.93 degree north, and that will give me, just divide by 5 to get rid of 5 from here, and we can just write like this. V is equals to 56.4 over 5 meter per second east, 52.93 degree north. Finally, just plug in the values in the calculator and you get 11.28 meters per second east, 52.93 degree north. So the combined, after the collision, the combined mass will move with this velocity and they will move in this direction.